Have you ever noticed that things get a little bigger when they heat up? That's thermal expansion. It's a pretty simple idea. When things get hotter, their molecules move faster and spread out a bit. This makes the object itself expand in size. Linear thermal expansion is just a fancy way of saying that this expansion happens in one direction, like when a metal rod gets longer when it's heated. Now, to measure how much different materials expand, we use something called the coefficient of linear expansion. It tells us how much a material will expand for every degree Celsius or Fahrenheit change in temperature. This coefficient is different for every material. Some things expand a lot when heated and some expand just a little. We can actually calculate this expansion with a handy formula deal equal sign, αLΔT. Don't worry, it's not as scary as it looks. dl represents the change in length. Alpha is that coefficient of linear expansion we talked about. L0 is the original length, and dt is the change in temperature. This simple formula helps engineers build all sorts of amazing structures, from bridges to buildings, by taking into account how temperatures change throughout the year. Linear thermal expansion might seem like a small thing, but it's a big deal for engineers. Imagine building a bridge without considering it. On a hot day, the bridge would expand, and, without enough space to grow, it could buckle under the pressure. That's why engineers include expansion joints in bridges. These gaps allow the bridge to expand and contract safely without causing any damage. Railway tracks are another great example. You've probably seen those small gaps between sections of rail. Those gaps are there to allow for expansion and contraction of the steel tracks as temperatures change. Without them, the tracks could buckle on a hot day, causing a dangerous derailment. Pipelines that carry oil or gas over long distances also have to account for thermal expansion. These pipelines are often exposed to extreme temperatures, and the expansion and contraction of the metal can be significant. Engineers use special expansion loops or joints to prevent damage from this constant expansion and contraction. Even buildings aren't immune to the effects of temperature changes. Concrete and steel, common building materials, both expand and contract with temperature variations. To prevent cracks and other damage, engineers incorporate expansion joints into the design of large structures, allowing them to breathe with temperature changes. Understanding linear thermal expansion is crucial for engineers to design safe and durable structures. From bridges and buildings to pipelines and railway tracks, accounting for the expansion and contraction of materials due to temperature changes is essential for preventing catastrophic failures. By using the coefficient of linear expansion and the simple formula we discussed, engineers can accurately predict how much a structure will expand or contract, ensuring that our buildings, bridges, and transportation systems remain safe and functional for years to come.